Yeah, we'll go ahead and get started. So, folks, welcome. Again, this is the first session that we're dedicating strictly to Ccna studies and folks trying to get some network fundamentals. So we're gonna, again, our guide is going to be the Ccna book, volume 1. And we're starting off by reviewing, the fundamentals, chapters 1, 2, and 3, introduction to network. Okay. So with that, if you guys have a piece of paper, what have you, I want you guys to write down these 3 things. Okay. So I can get to it. What's a little bit better? Let's do that. Where am I at? Nope. There we go. I want you guys to write down these 3 main concepts, because before we do anything, I need you guys to understand that, because this is going to be the groundwork for you guys being engineers, cybersecurity people, whatever. Okay. So let's find that page. Well, I'll look for the page. I'll go ahead and name it off. So there's 3 primary functions of a switch. Okay. So first primary function of a switch, one is to learn MAC addresses based off of the frame that's coming inside of the switch. Okay. Second main function of a switch is to forward frames, based on the destination MAC address of that frame. Third and last major function is to go ahead and forward frames. Last function is to go ahead and prevent layer 2 loops on redundant links using spanning tree. I need you guys to remember all 3 of those. Okay. And of course, you guys know about the OSI model. If you don't, we're going to go ahead and go over it real quick. Okay. So, of course, you guys see these big server rooms. You guys see your house. You see things that are plugged up, right? The OSI model can go ahead and be applied to any of that, right? So I'm going to use, PS5, for example, right? And using the OSI model, right? And we're going to start at the bottom, right? At layer 1. Layer 1 is called the physical layer, okay? And that's referencing, cables, wires, anything that's physical media, anything that, HDMI cable, power cable, Ethernet cable. That's your layer 1, that's your physical layer, okay? Anything that has to do with moving something physical, okay? The second layer, layer 2, right? So it's a layer that's very important, because again, this is where, the OSI model starts to get a brain, okay? They start to do some organizing, the little minions. If you guys ever saw that movie, they start, working. First part of that layer 2 is logical link control layer, right? And so that first part is, it's in charge of, management, sending those BPDUs. Okay, we'll get to BPDUs in a second. It's in control of, preventing spanning tree, what have you. But the other part of it, right, of data link and layer 2 is MAC addresses. That's how they communicate, right? In America, we speak English, okay? If I'm speaking to Brian or I'm speaking to Kanisha, I'm speaking in English, okay? That's how we can communicate, all right? So now the next layer, right? We're gonna go ahead and move up to layer 3, which is the network layer, okay? Has to do with IP addressing, right? Routing packets. We're gonna get to that. But first, we're going to go ahead and touch on layer 2, okay? Next, right, is layer 4, transport delivery, okay? Think about transport as if it's your mail service, right, USPS. It's making sure, if I'm writing a letter to Antoine, USPS is making sure it's getting from point A to point B, period, okay? We're going to keep it simple. And we'll go ahead and go into the technical terms later on, okay? So layer 5, session layer, okay? It's session management, okay? Connection management. It's making sure, okay, if we're still staying with the USPS example, okay? It's making sure that once the USPS service picks up my mail, it's making sure that it's getting to the mail office, okay? And the mail office is getting it to the plane, and the plane is getting it to the other mail office. Every time that packet, right? Because now it's called a packet, and we'll get to that later. Once it leaves from every device to another device, it's creating a session because it's making sure, all right, I'm leaving now. Now I'm going to my next destination, okay? So layer 5 is making sure it's controlling that traffic from point A to point B, okay? Layer 6, okay, data translation. What's happening now is it's making sure, right, if we're still staying with the USPS example, what's happening is the USPS is making sure, hey, even if it's going through different things or what have you, now we're translating. We finally got to the neighborhood or area where Antoine lives. Now there's a UPS truck that's preparing to go ahead and deliver to Antoine, because now we know how his address looks like. Now we can go ahead and say, hey, now we know where to drop it off at. It's for him because we speak that language within his neighborhood. And of course, last but not least, that mailman is going to go ahead and drop that mail off because, again, he knows the actual neighborhood. He knows where Antoine lives, okay? And you can think of that like network application protocols, okay? HTTP, DHCP, et cetera, okay? They're not the actual application. It's not Skype. It's not Teams. It's the network application protocol. I want you guys to make sure you understand the difference, okay? So before I move any further, because we're going to start having fun, any questions?
Not at this time.
Cool. Okay. So, guys, if you read chapter 1, chapter 2, chapter 3, okay, there's, you have layer 2, right? Every port on the switch is a collision domain. Collision domain is typically, let me get my handy dandy drawing pad. Give me 1 second. What color I want this? Let's make this purple. That's a good color. Okay. That's a collision domain. That's a collision domain. And you want to think of the collision domain as a, its own, from one person to one person, right? From Claude to Brian, that's one conversation, okay? But then if Claude wants to start a new conversation with maybe Kanisha, maybe Joe, this is another conversation. So think of collision domains as that, okay? It's physical media, right? That's controlled by, and of course in a switch sense, it's controlled by one wire, right? Back in the day, if this was a hub, okay? Let me go ahead and erase this. If this was a hub, a collision domain would be this big. So you guys can think about what would happen if Claude is in the middle, Claude is that switch, and Kanisha and Joe's trying to talk to Claude at the same time. Brian, what do you think is going to happen if Joe and Kanisha's trying to talk to Claude at the same time?
If they try to talk to each other at the same time, you really won't get an understanding of what is really being said because they're both talking at the same time.
Exactly. Okay. So there's going to be collisions, right? So let's think of PC has Kanisha, right? And let's think of the server has Joe. If they both trying to talk to Claude at the same time, which Claude is being switch one, there's going to be a lot of collisions. Okay. So, taking a little history lesson, what they had to do is they had to go back and say, let's make this more efficient because data isn't traveling efficiently and it's taking a lot of time to get work done. So we're going to go ahead and improve, okay? Improve physical media. And guys, stay with me now. We're going to go ahead and split up the collision domains per port on the switch, okay? So now the switches are smarter now. They were made to be smarter. So each port on the switch, remember this, is considered a collision domain, okay? So it won't get interrupted by any other device, okay? The port on PC6, Kanisha, is talking to you know, is talking to Claude, right? Having that one conversation. Then, right, the DHCP server, being Joe, is waiting her turn, not truly, right, in a switch sense, but she's talking to Claude separately, okay? So that's how you want to think about it, okay? But, right, we're going to take this a little step further. Now that we have separate collision domains, right, and we're still at layer 2, right, a layer 2, you know, if there's no separation of, you know, different subnets, different networks, and we're going to get to that, this entire, all the way up to, you know, if there's no router, no layer 3 boundary, okay, this entire network is a broadcast domain. And who do we have here? Let me see who we have in this list. Who do we have in the participants list that I can call on? Oh man. So Claude, what would be a broadcast domain in your words?
So a broadcast domain is basically, just look at it like this, an area where people can hear you. So what does that mean?
Okay.
Let's say you standing in the middle of your cul-de-sac in your neighborhood and you yell, and people have heard me use this analogy before, and you yell, everybody in your cul-de-sac, you may have an additional 4 neighbors, 5 neighbors in that cul-de-sac, and you stand in the middle and you yell, those neighbors can actually hear you, okay? That's a broadcast domain, as opposed to going down the block, crossing over the intersection into that cul-de-sac. They can't hear you because that's a whole different domain down there. So the same applies for these here network devices. You got PC6 in that illustration that he circled up at the top. When it speaks, there's going to be a certain group of devices that hear it. And then there's going to be a certain group of devices that do not hear it, which is a totally another domain. Does that paint a picture?
Does that make sense? All good. I'll take the silence as a yeah. Okay.
Yeah.
So
That makes sense to me. That makes sense to me.
oh, it's all good. It's all good. So guys, with that example, right? Going back to what Claude is saying, right? And going back to what I stated, right? Claude used the real world example in layman's terms, and I use technical. If we combine both of those, right? So if we go down to the second network, right, where PC7 is on, right? We know the definition of collisions and broadcast domains. With the theory now, right, we're going to apply it to, you know, a real world example. The router, right? Routers, their job, right? Their specific job is meant to separate networks and route packets, right? At a layer 3 level or boundary, right? With that being said, each port on a router is a broadcast domain. So if this neighborhood is Claude's neighborhood, and this is my neighborhood, Claude probably stays in California. I stay in Louisiana. Claude is yelling, right, in his neighborhood, in his cul-de-sac. There is no way I should be able to hear him at all. Because that router, right, Claude being PC7 and me being DHCP server, I won't be able to hear him because we're separated by that router, right? And going back to the real world example, we're separated by states. So I won't be able to hear Claude. So that's the application of broadcast domains, okay? All right, so with that being said, let's dig a little bit deeper. And guys, before I move forward, any questions?
All good so far.
Oh, I'm good.
Everybody all good? Cool. All right, so let me go ahead and let's clear that. Cool. All right. So in this first network, right, up top, right, we have a network, and we're gonna call this Claude's neighborhood, right? Claude's neighborhood is up here. And what we're gonna do is PC6 is going to be Claude, right? And Claude is going to yell, okay? He's going to yell and scream, asking for the ice cream truck, okay? And we're going to see if the ice cream truck, being the DHCP server, can hear Claude, okay? Now, it should hear Claude, right? Because there's nothing separating Claude, you know, from the ice cream truck, okay? Ice cream truck's on the street, Claude hears them, he should hear them, right? There's no boundary between Claude and the ice cream truck. So let's test this, okay? Give me 1 second. Let's go ahead and pull this up. Okay, all right, so here's Claude. And here, let's go ahead and start capturing some packets. And guys, the reason why I'm going to start capturing packets, I want you guys to, you know, take a look at how the OSI model looks on the wire. Okay, but we'll take a look at that in a second. So the wire shard. There we go, perfect. Okay, so what we're gonna do first, we're gonna see if Claude can hear the ice cream truck, okay? So what I'm gonna do here, right? I'm gonna use a protocol from the OSI model, right? And I'm gonna use a protocol that's at layer 7 called DHCP, right? Jose, do you know what DHCP stands for?
Yes, sir. It's the dynamic host protocol.
Perfect, exactly, right? And so what it does is DHCP, it assigns, if you guys don't already know, and I may be repeating because I know some of you guys are already working in IT, or you know, if you guys aren't working in IT, you've probably seen it before. But DHCP is a way to where a resource can dynamically assign, right, an IP address to a PC that joins a network. In this case, right, we're trying to get Claude to get an ice cream cone from the ice cream truck, okay? As long as it's in that same neighborhood. So we're gonna see if Claude, when he yells, right, us sending that DHCP request, see if the ice cream truck is gonna hear him, if he gets that IP address, okay? Claude, I don't think you're gonna get some ice cream today, bro.
It's like getting the ice cream up.
Claude, I don't think you're getting ice cream today, bro.
What's up? Say it again.
Nah, I was making a joke. Nah, so of course what I was tempted to do is have you scream for the ice cream truck, basically sending a DHCP request from your PC. So you didn't get that, okay? So we're gonna go ahead, let's take a look. Let's check something here.
We on the top topology or the bottom topology?
We're at the top topology.
Okay.
Okay. Now, let's see if we can hear Claude now.
There we go.
Okay, still can't hear Claude. So I'm going to do some due diligence on my side. Guys, I would show you this, but I do not want you guys to get confused. So give me 1 second. That would work. There we go. Okay, so now let's see if Claude can get his ice cream cone.
Come on, Claude.
Claude, I don't think you might get an ice cream cone today, man. And there we go. And let's just double check that. Make sure everything's rolling. Brief. Let's test that. Claude, you may not be getting ice cream today. Take a look and see what's going on.
Did you fix it real good?
Hey man, hey man, my generator might be out. My generator might be out. Okay. There we go. Okay. Let's go ahead and stop that. Bring that up. Okay. Let's see this. There we go. Let's now. Well, it should be working now. There we go. Okay. Claude, you might have got your ice cream. Okay. So now that that's completed, Claude was able to get his ice cream. Why? Right? Claude was able to get his ice cream because they both live in the same broadcast domain, right? The ice cream truck, which is the DHCP server, and the PC were both in the same broadcast domain, right? Now, let's go ahead and shift it, right? What's going to happen if we go ahead and we move here? Okay, we move to that second network. So, you know, I'm the ice cream truck, right? But I'm in a different neighborhood. I'm all the way in Louisiana, right? Claude is still in California trying to scream for the ice cream truck at the top of his lungs, okay, from California, right? So with all this being said, Antoine, should Claude still be able to get ice cream or an IP address? Why or why not?
I'm sorry, repeat that one more time.
I got you. So Claude being PC 7, right?
Right.
If he's trying to get an IP address from the DHCP server or get ice cream, right, from the ice cream truck, which is a DHCP server in this example, should he still be able to get an IP address?
Technically, yes. Technically, yes. But not so fast.
Okay, so let's keep it simple. Don't
Okay.
add, I know what you're thinking. Should he still be able to get an ice cream? Just like how he got it in a layer 2 network.
No,
Should he still be able? Why?
because his request is strictly on that broadcast domain.
Exactly. Right? Because the DHCP server lives on a different broadcast domain. It's not going to hear those broadcast messages or Claude yelling, saying ice cream truck at the top of his lungs. Ice cream truck. It's not going to hear him. Claude's going to be yelling for no reason. They're going to think Claude is crazy. So then they're just going to pull Claude inside. Sorry, Claude, you might be a little bit crazy. Okay? So, Antoine, great job. So this is what Antoine was talking about. We're going to need a way, right, to make sure that packets that are on a layer 2 level, right, which is broadcast packets, can be sent across a layer 3 boundary, okay? We're not going to get too in-depth into that just yet. We're not going to touch layer 3 yet. We're still staying at layer 2. I just want to show you guys, right, how layer 2 works and, of course, how the functions of a switch work, okay? So let's go ahead and pop this bad boy open. Okay. See if this bad boy can get an IP address. Let's take a look at everything. Where's Claude at? There we go. I'll let you guys take a peek at this. And the guys, the DHCP server is basically a router that I'm using. So let me go ahead and using has my DHCP server. Okay. Perfect. There we go. Forgetting one thing. Perfect. So that's taken care of. Now, let's check this. And now we're going to take a look at the routing table. But again, I don't want you guys to worry about this. Here's a couple of points that I want you guys to see, okay? So on R4, right, this is what separates Claude and the ice cream truck, okay? There's a big street, a big highway that separates Claude. You're gonna think of the route that has a big highway, okay? So the highway can see Claude Street. You can see Claude Street from the highway, which is Claude Street is 10.0.0.0, that network, okay? The ice cream truck is on this street, right? Or 172.16.1.0, okay? So that highway is responsible for making sure that communication between Claude gets to the ice cream truck, right? And realistically, of course, ice cream truck, the guy might have some good ears if he can hear Claude, but typically he can't, right? So the ice cream truck guy has to get over the highway to reach Claude, okay? So that's where of course, the highway or the router comes in, okay? So we can reach both sides. Let's go ahead and just check one thing, and this is what Antoine was talking about, to make sure that that broadcast can go ahead and reach it, right? It's a mechanism called an IP helper, right? And we'll get to that in our later sessions, right? But this is a way to where Claude calling, right, for the ice cream truck, what the router is going to do, right? Claude requesting an IP address from his PC, it's going to forward that broadcast, right? That's at layer 2 and send it via layer 3. Because typically the rule is, right, broadcast packets, right, broadcast frames are not forwarded past a layer 3 boundary, okay? So going back to the real world example, Claude shouldn't be able to yell for the ice cream truck from his neighborhood, and the ice cream being a highway over shouldn't be able to hear, okay? But we're gonna put some magic in this place, okay? So here's where the IP helper comes in. Now, with that being said, let's just make sure all the interfaces are on. Good and dandy. Let's check the router. Let's bring that bad boy over there. Cool. All right. So now, see if Claude can get his ice cream today. Let's see. Claude, you might be out of luck, man. You might not be getting your ice cream today, dog. Let's do this.
Eddie Murphy said, I got some ice cream in you.
He's so stupid. All right, so let's boot this bad boy back up. Give it a second. And guys, this is where real devices would actually come in, right? Virtual devices are good to get the proof of concept. But again, virtual devices, software does have its issues. So as you can see, I'm troubleshooting multiple times trying to get this issue corrected. So let's see what's going on. There we go. Let's keep Claude right there. Let's check that as well. Make sure he's squared away. And guys, once these switches come up, right, what I'm looking for, right, is if we're going back to the OSI model, that layer 1 and layer 2 is working. And we're going to get deep into that soon before we before the session is up. And again, we're going to end roughly at 9:15, but we're going to touch on layer 1 and layer 2 and why that's important for switching, and before we get to layer 3, which is routing. Okay, let's take a look at this. So interface brief. Let's take a look at our interfaces. Perfect, our interfaces are up and running. And let's take a look at our other interface. Make sure they're up and running. Perfect, so they're up and running. So everybody's good. And let's double check to see that everybody's good there. Perfect. Everybody's good there. Now, that being said, Claude should be able to get an IP address. Claude, you got your ice cream, man. You were finally able to get your ice cream.
See it.
You happy?
Claude.
I see it.
Good. You got your ice cream, man.
Yep.
So, guys, right? Say all that to say, because this is how networking works. Okay. First needs to make sure layer 1 is working properly. Okay. There's a cable connected. Is it working? Then we're going to jump over to layer 2. Right? The switch, typically, right? We're going to keep it simple. Layer 2 being the switch, right? It's control of it's in control of learning MAC addresses, right? Its main purpose is to make sure that it switches, it forwards frames based on the source and the destination MAC addresses. Okay? Remember those 3 major functions. Okay? So, with that being said, we're going to take a look at something. Okay. Here's that MAC address of this PC. Okay. If we go to switch 2 and we're using the OSI model, that MAC address should have been learned from switch 2. Okay. Okay. So as we can see, that MAC address was learned here. Okay. All right. So that's what it's in charge of. Okay. So if I go ahead, right, and we're going to do a little bit of path of the packet. Don't get too excited. We're going to take a look at this. Give me 1 second. I didn't want to graph. Pop this. All right. And let's pop this. Okay. So guys, we're doing a Wireshark capture. Okay. And remember the application Wireshark, right? It's meant to capture packets, capture data, capture these network packets that are flowing through the network per on the wire. Okay. So it's sniffing your wires, seeing what's coming in and out. Okay. So it's doing that in the background. We're going to take a look at how that works. But what we're going to do is we want to see how that works. So what we're going to do, we're going to go ahead and see traffic coming between one device, right, this PC, from one broadcast domain to another, right? And we're going to see what changes between both, okay? And this is very important for, layer 2 and layer 3 and knowing the difference, okay? Let's do an extended one. So let's let this keep going, right? So what I have here is I have, this PC, right, pinging the DHCP server, okay? So we're gonna leave that right there. And what I'm gonna do, we're gonna pop open the DHCP server. We're gonna let that sit right there. Okay. While that's going, Jose, I got a question for you.
Yes, sir.
Whenever a packet is traveling, right, a layer 3 boundary, does the IP address change or the MAC address change?
The IP address changes.
Really?
I believe so. Wait.
Think about the USPS example, right? If I'm sending a letter to Antoine, if I'm sending a letter to Antoine, right, and USPS being the router that gets it, should USPS change the name to Kanisha?
No, it shouldn't. It shouldn't.
Okay.
Yeah.
Okay. So
Yeah.
I'm going to ask you this again. What changes whenever those packets travel through a layer 3 boundary? Is it the IP address or is it the MAC address?
The MAC address.
The MAC address. Absolutely. Okay. Guys, remember this and put this in your notes. Okay. Whenever a packet is traveling from point A to point B, there's specific cases where there's, gotchas in this rule, but mostly the source and destination of a packet, that IP address will never change. Per hop or per device that it comes in and leaves out, it's going to change. So layer 2 is always going to change whenever it leaves from one device to another device. Okay? Let's take a look at how that looks. All right?
So like you said, that letter goes to Antoine, but that stays the same. But what that letter does do, that letter does change mailing process facilities. So it's going to stop at one post office in this state, stop at another post office in another state, stop off at another processing center in another state. But the ultimate destination of Antoine is going to stay the same.
Let's leave that. Let that keep going. Then okay. Okay. So let's let that keep going. And let's take out my notepad. Okay. So the source, right? The source MAC address or the address of Claude, right? You take a look at that. This is his MAC address. Where's my? There we go. Here's his MAC address. Now, let's go ahead and go to switch 2, and let's get that MAC address of the interface that Claude or PC7 is connected to, okay? Show MAC address, table, perfect. So we have Claude's MAC address, and it's being learned on this interface. So let's check the information on that interface. See if we can get that MAC address. So that's a lot of information. Let's go ahead and trim it down a bit. Okay. Let's use that. Okay, so that is the MAC address of that interface. And let's just match up and let's just see if that matches up, okay? Let's go ahead and pull up that text editor again. Pull that to the side. Let's start doing some pings again. Okay. There we go. There we go. Perfect. So you guys see it? You guys see these packets traveling? What's the MAC address that we see? Do we see that interface's MAC address?
Oh yeah, I see it.
Yeah, I see the interface, the MAC address from the switch, the interface on the switch.
We do?
Yes, I do see it right there.
Really?
Yeah.
Positive.
Yes.
So this matches up with that.
Oh no, I'm sorry.
this is-
I'm looking at all the packets. It's going crazy on Wireshark. I'm
It's all
sorry.
good,
I wasn't looking at
it's
that.
all-
My bad.
It's all good, brother. So again, right? So let's keep it simple, okay? The switch, right? And again, that was a doozy. I wanted to throw you guys off, right? So the PC, right? And the interface, gigabit 0/1 on the router is part of the same broadcast domain, right? So think about that interface being me and Claude being Claude, that PC. I can hear Claude if he yells for the ice cream truck. I'm gonna tell Claude to shut up. He's yelling too loud, right? I can hear him, right? So me and Claude are gonna be able to talk to each other. But the ice cream truck, being that DHCP server, won't be able to hear Claude. It's on the other side of that highway, okay? So if we look at that capture again, right? That interface, right? That's me. That's who can hear Claude, right? Because the switch, all it's doing is its first two duties, right? Learning MAC addresses based on the source MAC address, which is Claude. It has it right there. And forwarding MAC addresses, right? Forwarding frames based on the destination MAC address within a frame. It's forwarding it to me. Keeping it simple, guys, right? Now, right? And so that interface, right? We're gonna keep it short. That interface just belongs to me, okay? That's that interface right here, gigabit 0/1. Now, take note, okay? Take note of that interface. With everything being considered and what we've talked about tonight, Kanisha, should that MAC address of Claude, right, or PC7 be seen from this switch 3?
No, it shouldn't.
Why?
Can you pull up topologies again?
Gotcha.
So you're saying if Claude is yelling for ice cream across the highway, should the switch that is connected to the ice cream truck hear him? Actually, yes,
Right.
because that's what the router's job is.
Okay. Let's say the router or the highway, right? There's a lot of traffic passing through it, right? And it doesn't know how to, tell the ice cream truck, hey, go here, Claude is yelling from you. From a theoretical standpoint, right?
Mm-hmm.
If Claude is yelling from his neighborhood to the ice cream truck, that's across from the highway.
Mhm.
Should the ice cream truck be able to hear Claude?
No.
Okay. So again, guys, broadcast packets, right? Broadcast frames are not typically, right? And we're talking about layer 2 now, are not typically forwarded past a layer 3 boundary, right? It's not forwarded past that router. Okay. So those MAC addresses, right? You see how whenever we look at the MAC addresses here, I was able to see in that packet, I was able to see Claude's MAC address and my MAC address, my street address and his street address. Can't see where the ice cream truck address is or where he's at. I can't see it on this side. So if I go ahead and look at the interface, right? Let's look at a packet where it's sourcing from Claude. And let's pull up our text editor again. Do we see Claude's address here on this switch as the
No.
source? Okay. Remember, guys, keep this in mind. Whenever you see a packet, only the MAC address is going to change per hop, meaning per layer 3 boundary. That's going to change. The IP address will never change, no matter how many, if it has to go from google.com to your PC, it will never change. And again, there's certain instances, right, where that's true and untrue. But again, typically, it's not changing. The MAC address is the only thing that's going to change because it has to go from, mini point A to mini point B. But the global point A to point B will never change. Okay? Okay, with that being said, guys, I think that's enough for this first session. Any questions?
Okay, so help me out. So technically the
Okay.
router was an ice cream helper.
Yeah.
Okay.
Basically. Yeah, the ice cream helper.
Okay, all right. I think I got it now.
Listen. Hey, I'm giggling because David knows I am probably the king with layman's terms when it comes to networking. And I was just sitting there thinking of that label you just gave that right there, and it's all good because it's all about you understanding what it is. When he was talking about Twan getting a letter earlier, he was using the post office as an example, and I just went along with that. I went along with him. The thing is, that letter mailed from California to get to Twan, wherever he's at, that address stays the same. That's layer 3. But it'll go from one post office to another post office to another post office to a processing center. It may have 5 different stops before it get there.
Yep, zip code to zip code.
Yeah,
to zip code,
exactly.
There
That's
you go.
layer 2. That's layer 2. So I'm giggling because I'm relating with you when you're talking about the ice cream helper. Do you see what I'm saying?
Yeah.
So please don't take offense to me giggling like that, please.
No, man, no. I knew why you was giggling.
And we're gonna get to that, guys. We're gonna get to the ice cream helper. We're gonna get to that. But again, the primary focus is layer 2, guys. Okay, layer 1 and layer 2. Okay, we're gonna review this again. Go ahead. Somebody has a question?
Yeah, I got a question. Claude, what flavor is the ice cream?
Oh my God.
Napolitan.
That's a vanilla butter pecan mixture. That's what that is right there.
Oh, okay. I'll have to get me a bucket.
What up,
Oh,
King? What's
God.
going on, bro?
I'm
Guys,
good,
good
man.
stuff.
I'm good. How are you?
I can't complain.
Oh, nobody's
Good
listening.
stuff, fellas.
Now I knew why you took the DHCP part off screen.
Say it again.
But why you took the DHCP off screen while he's trying to figure out how Claude can get his ice cream. But since since you're recording these videos, that might help somebody later on when I'm trying to figure out why DHCP isn't working, actually seeing what you did. But I know why you took it off.
No. Hold on. I didn't want to show that just yet. We're staying at layer 3. I mean, we're staying at layer 2. I do not want to confuse anybody just yet. It's very critical because Claude knows whenever I was working at Cisco at TAC, right? So many engineers have the title of engineers, but don't ever use the OSI model to troubleshoot. As soon as there's a network issue, you're jumping to layer 3. There's 2 more layers before that. So it's very important to where I'm focusing, and I want to keep you guys focused real simple. And we're going to keep it at layer 1 and layer 2 for this first session in these first 3 chapters. Don't want to confuse anybody about layer 3. We'll get to that. We'll have fun with that with OSPF and troubleshooting. Oh, we'll have that fun later on. We're going to keep it simple. Layer 2, layer 1. So good question. I could have troubleshot it with the, of course, recording, but no, I made the executive decision not at this time.
Got it.
Okay. Guys, any other questions? Great statement, Christian, by the way. Any other questions? All right. Well, I'll take that as a no. I'll go ahead and end it here, folks. I will go ahead and let you guys know when our next CCNA session is. Again, we're still on chapters 1 through 3. So again, take a look at it whenever you can. We're going to be reviewing again layers 1 and layer 2 at the next session.
And this is volume 2, right?
You guys have a great night. Nope, this is volume 1.
Volume 1.
CCNA
Okay.
200,
Volume 1.
301. Yep, we're starting slow.
Okay.
Starting slow. Kanisha, by the way, I know this is your first session. Did this help out in any way?
Absolutely. I'm just a little rusty because I have taken about 2 weeks off. So yeah, I had a couple of dumb moments, but absolutely very helpful.
It's all good. It's all good. And again, it's recorded. So guys, feel free to watch the video. I will be posting the video in our Slack. Okay.
Hey,
Gotcha.
for supplemental, if you go into I think most of y'all are members of the growth and network engineering. If you go into the general room, and like I said, this is just supplemental. If you go into the general room and do a search on the word PlayStation, you will get some more supplemental on layer 1, layer 2, as I walk through the process of layer 1, layer 2 with a PlayStation 3 on actual gear. So you, like I said, what you'll see on there is taking a PlayStation 3 from straight power up to going through some layer 1 and layer 2 stuff to eventually get to layer 3. But like I said, it's good supplemental to what you saw tonight.
Got it.
Absolutely. And guys, again, you guys have access to that Slack at any point. You guys thinking, I don't care what time it is, you can shoot myself, Claude, a message. Hey, what did you mean by that? That didn't make sense. That's what we're here for. Feel free to shoot us a message. And it doesn't have to be just me and Claude. You can shoot it to any other member in the group. If they don't know, they'll shoot it up to us or anybody else.
Yeah.
We're here to help you guys for free. No paid, no nothing. We want you guys to pass the exam, but also to be great engineers.
And we appreciate it, man. Thank you so much for the help.
Absolutely.
No problem. All right, guys, I'll go ahead and let you go. Claude, go eat your ice cream because I know you've been shouting top of your lungs.
Will do.
Okay. Good night, everyone.
Good night.
All right. Take care.
Folks.